Right. Hi everyone. So we'll be starting in about 5 minutes. Start at 2 o'clock. In a couple of minutes, I'll go through a bit of the kit that you might need for today, but there's not that much for today. Hi everyone, so we're just going to start in a couple of minutes, and I'll have a chat with you in about 1 minute time just to tell you what stuff you're going to need for today. It's not much. The main thing you're going to need is just some A4 paper. What we're also going to do, if this is the first time you joined us, hello. If you've got a plastic bottle to hand, that's great. Otherwise, you can do this one tomorrow. And some paper we're going to cut into that sort of shape, or you just get a bit of paper, bit of plate, something in a circle, and draw around it. And what you can do is you can just start cutting those little shapes out. It's that shape there that we're going to need for today. Right, we'll start in 3 minutes. So 10 minutes. Got more people joining. Hi everyone. So all you're going to need for today is just some A4 paper. It's a little bit of folding today. If you can, if you've got something circle you can draw around, like a plate, just get a corner of a paper, just draw around there and just carefully cut this out. And it's this bit here that you're going to need. You'll need some sellotape for this one as well. That's more for the teachers of the grown-ups. What we've got 1 minute to go. I'll tell you what, I'm going to have to sit down. I'll have a little chat with you. Now, which way am I moving? That way. There you go. I'm not going to start just yet. We'll start in about a minute's time. So I'm going to quickly go through the equipment that you're going to need for today before we get started. So the main thing you're going to need for the experiments and your task for after is just an A4 sheet of paper, or even a few A4 sheets of paper. If you've got some colouring pencils or pens, that'll be brilliant as well. So you're going to do 3 experiments there. Now, if you were with us for our solar system session, I showed you where I made a little rocket using a bit of paper. Because today's session is going to be about flight, you're going to make a rocket. So you're going to need a bit of paper, kind of like this shape here. Put that over there. So kind of pointy shape there. Now, one of the easiest ways to make that shape is to just get a bit of A4 paper, get something circle, draw around it, and the bit of paper you're going to need is this bit here. So this side of the circle. You can just use the rest of it to do even more. So the grown-ups could do a bit of work getting them ready for the boys and girls. If you do have some sellotape, you're going to need that, because what we're going to do is you're going to turn this into a corner shape like that. So what we've got for time, we've got it's 2 o'clock, so I'm going to start now. I'm trying to be tidy, but I've got quite a bit of stuff to do. So, hi everyone, it's Neil. I'm back with another Science with Neil science session for you all to do at home or at school for British Science Week. Now, this is the 4th session. I think it's the 4th session. The other 3 sessions, the solar system, the forces session with friction, and the floating and sinking session, they're still available on this channel, so you can still go back and watch them. Today's session is going to be about having fun with flight. Now, flight, having fun with it, we're still going to be talking about forces. So we'll be talking more about forces, but having fun with flight. Now, today there is 3 little science experiments or activities that you're going to be doing. The first 2, I will show you how to do, and then the task for after, you can start making them and you can watch this back. I'll give you a little bit more information. And there's also some more experimenting you can do after the session as well for your after the session tasks. So when I've gone, you can have fun doing all this fun flying science. Then for the 3rd experiment, we'll all do that together. But I'm probably going to do a couple of little demonstrations first, just to teach you about what's happening and how we get things to fly. So I've got quite a bit of stuff to do. So when we're talking about flight, we have to talk about forces. So if you remember, I would have had my apple today, but I ate it yesterday by accident. So I'm going to use my paper aeroplane. So when we're talking about forces, I'm just going to move some of this as well. When we're talking about getting things to fly, we have to talk about forces. Now, if I put this paper aeroplane on the table there, it just sits on the table. Now, if you remember off Monday, when we were talking about forces and moving things around, all the forces acting on this paper aeroplane now are balanced. So the gravity is pulling it down towards the table, and the table is pushing up against the plane. But that's at the same level, so they're equal. The forces are equal, so it's not moving, and it's not moving left or right or sideways because there's no thrust, so therefore there's no drag or anything acting on it. Now, to get planes and helicopters and anything to fly to not be sitting on a surface and to be up here where we want them to be, we have to provide them with this thing called lift. So we need something to lift it up, just like my hand's lifting up, but that's not flying, that's just sitting on my hand. We want to give it lift, and this is the thing that makes things fly. Now, I'm going to talk about lift for a while. So just think like a lift in a big building, goes up and down, it lifts it up. So we need something to lift our paper aeroplane up. So I'm going to tell you how we do that. Now, to do that, I'm going to have to talk about this thing called air pressure. Now, I'll just quickly tell you what air pressure is. So air pressure, like this, say for example, this plastic bottle. This plastic bottle, it's got air in it. If I squeeze it, the air comes out. If I leave go, the air is sucked back in. But if I put the lid on this bottle and then give it a squeeze, you see a squeeze, it then pushes the bottle back out. And that's because air pressure inside of this bottle, it's a certain size or volume, so it's 2 litres this. It has some air in it. Now the air is made of these things called particles, or for the young ones, it's made of stuff. The air isn't made of nothing, it's still got lots of these little things called particles in. And when these little bits of stuff, particles, move around, they're moving around because it's a gas, they're free to move around, they kind of bash off the sides. And what pressure's in this bottle is kind of how much stuff is pressing onto the sides, onto the surface. So all you have to think about is pressure, and air is made of stuff or particles. And that's what we use to make things fly. Now, one of my favorite things about science, it's using kind of random daft objects to try and explain some science. So you're taking everyday items and using them to explain something quite tricky. So what I'm going to do is today I'm going to use an empty can of pop and some toilet roll. And I'm going to use these 2 things to tell you how things fly and hopefully show you how things fly as well. So the first I'm going to use is my can of pop. So I'm going to put the can of pop in here. Now this is a really good one. This is a good one for grown-ups. Grown-ups have just as much fun with this one as boys and girls. So what we're going to do, it's almost a little challenge. You can do this at school, you can do this at home. All you need is 2 cups where the can fit in both cups. Now the challenge is you have to get the can to move from this cup to this cup. Sounds easy. You could just pick it up and tip it in. That's it. But you can't touch the can. You can't touch the can or the cups. So now it sounds a bit more tricky. So what we're going to do is we're going to use some science to get this can to move from this cup to this cup. Now this is pretty hard. So I'm just going to move them that way and that way. So I've got to get it from there to there. I won't do this first time. If I do this first time, I'll be very happy. But what you do is you just blow. Didn't work first time. Move it away. Third time lucky. Fourth time lucky. I'm not going to try more than 5 times maybe. Get closer. Oh. 6th time lucky. So can you see the can moved from this cup to this cup, and that is because of air pressure. So remember how much stuff is in a certain space. So the air all around you now, if you look all around you now at the air around you, that's all at the same pressure. And so is the air around this can and around the 2 cups. It's all the same pressure, either in the cup, in this cup, all around. When I put the can in this cup, the air pressure is the same all around here as it is underneath the can as well. But when I blow into this can here, when I blow down the side, because I'm blowing more air that goes underneath the can, the air underneath the can, there's more of it, so it becomes a higher pressure. So the pressure, there's more air underneath the can than there is in the same space than is around it. So what happens is the can starts to move. Now things move from a high pressure to a low pressure. So that's why the can lifts up. And it lifts up like that, and that's what lift is. So it can get lift from changing the amount of air in a certain space. And then because I'm still blowing that way, it moves it that way. So I'm not going to use this cup. I'm just going to show you. If I blow down, it changes the air pressure and the can jumps out. 3, 2, 1. It gives it lift. Now, if you're going to do that at home, make sure you give yourself a few goes at getting it in the cup, because it is quite tricky. Now I'm also going to talk about air pressure again. Don't worry, I'm not going to talk about air pressure for the whole time. We are going to actually do some science, little experiments at school as well. But I am going to use some toilet roll. So toilet roll, this is now, because when we do our live sessions, I do this in that, I kind of use the toilet roll a lot. And I always say, is toilet roll fun or is toilet roll boring? And it's usually, all the adults say boring, all the boys and girls say fun. But hopefully I'm going to make it fun. So what I'm going to do is I'm going to lift this bit of toilet roll up here like that. And then I'm going to leave go of this end. So what will happen? Will the toilet roll go up or will the toilet roll go down? So have a think, you can even shout out. I'm just going to leave go of this side here. Will this bit of toilet roll go up or will it go down? So we'll test in 3, 2, 1. It goes down. Now hopefully you all said it goes down, because you're thinking that gravity and its weight, its mass will pull it down. And you are right, you're perfectly right. That's what happens. If I let go, the force pulls it down. So we need to give this thing lift. Now, this is one of my favourite facts. It's one of my favourite films. When my son was young, he always used to watch Cars 2. And Cars 2 had a Formula 1 car in it called Francesco Bernoulli. And I'm going to talk about this man called Bernoulli now, because Francesco Bernoulli is named after this man. And this is all about air pressure. So if you blow, you move the air quicker. So when you blow, the air moves quicker. Now, when you make air move more quickly, it becomes a lower pressure. So what happens here is if I blow, I'm going to go this way. If I blow onto this toilet roll, even though I'm blowing on top, you would think I would blow the toilet roll down. But because I move the air here, what happens is the air here moves quicker than the air here, so things move from a high to a low pressure. So I've got to prove it. So in 3, 2, 1. So you can see it lifts it up. So that's a really good way of showing it moves almost kind of the opposite way as what you thought. You thought if I blew on it, it would push it down, but it's not, because it's this change in air pressure. And this is how an aeroplane's wing works. So aeroplanes' wings are designed to make the air move quicker over the top than it does on the bottom, and which makes the wing. I'm going to show you all how to make a paper aeroplane. It doesn't sound sciencey, but it is. Making paper aeroplanes is science. So what I'm going to do is I'm going to show you how to make one. So the science works right on it, and some mistakes that you might make. Now this one, you can try and keep up with me. I'm just going to go through it super quick, and what you can do is you can watch this back, and this could be one of your tasks at the end, and you can design it and do a little experiment with it after. So what we do is we need a sheet of paper. I thought I had it ready. So we've got one sheet of A4 paper. So the first thing you need to do is you just need to fold these two sides together like that. So the fold goes right the way through the middle of the paper, and then you open it up. So the fold goes right the way through. And then the next thing you need to do is you get this point and this point, and you fold them into the middle like that, and then that one like that. I'm just going to quickly go. Just next to middle's fine. So that one's there. See, that one's down like that, and then that one goes into the middle as well. And then what we do is we take this line here and this line here, and we fold those into the middle as well, like that. Now what we do in that is we're making it more, for the second fold, we're making it more streamlined. So what that means is it moves through the air quicker, so it'll look like that. So the air resistance, one of the forces that's going to try and slow our plate down, it doesn't have such a big effect as if we do it that way. And then what we do is we just fold it into the middle like that and give it a good tight fold. So it's all nice and tight like that. Now this is the bit where we've already a little bit of science there with the air resistance and the streamline, but this is the really, really important bit when you're making your paper aeroplane. Sometimes what people do is they'll give it wings, and they'll just give it a little wing like that. So that's where the scientist has to think, well, what makes the aeroplane fly? It's its wing, it's the air moving over the top of its wing. So if the wing is bigger, that change the difference in the air pressure is going to be bigger, which helps our plane fly. So what you do is you fold it to just about a centimetre or two from the bottom. Let's quickly show you. So you're going to give it a big wing like that, with just a little bit at the bottom, and not just a little wing like that. Can you see? So we've got a nice big wing, and then you just turn over and do it on the other side. And then we've got our pointy aeroplane, which is streamlined, so it travels through the air quicker, and we've got nice big wings. So when you give it when you throw it, that's giving it thrust. So you're giving it power. The air starts to move quicker over the top of the wing than it does the bottom wing, and then it flies. It keeps on going through. The air pressure changes, but then as it slows down because of the air resistance, eventually does slow it down a bit. It loses that lift, and then that's when it'll crash back down to earth. So that is just making a paper aeroplane. So don't worry, watch that back and try and see at the end. We're going to give you a couple of little tasks to do. So I'm just going to put that one there. But the next thing I'm going to do, and I'd love you to try this at home, I'm going to show you something else that's a type of paper aeroplane, but it doesn't look like a paper aeroplane. It just looks like it shouldn't fly, but it actually flies really well. And I'm going to tell you about the science. So again, all you need is a piece of A4 paper, and you're going to fold it, this top edge here, down about a third of the way. So a third, you've got to think of it, you split the paper up into kind of 1, 2, 3, and about a third of the way down like that. Doesn't have to be exact for this one, but a third of the way down. So it's just like that. You see there's the bottom, there's the top, and about a third of the way down. Now again, you can watch this back. Now this video is just this video for a tube plane is on our YouTube channel, this YouTube channel, Big Science UK, and it's just actually this one, so you don't have to watch the beginning or the end if you don't want. And then what we're going to do is you fold this side down to this little flap here. So it's that line there, goes straight along that line there. So we'll just go there. So you see that there, just fold it down to that line and you give it a real tight fold there. And then we do the same again. We're going to take this bit here down to this bit here. You see that? And then so that bit there goes down to that bit there and then give it a nice tight fold. Then when you've got this bit, you just give it a nice flatten on your desk and you give it a nice flatten so it's nice and tight. Now, I kind of gave away what type of plane I was going to make when I told you the name of the, the video on YouTube. It's a tube plane. So it's going to be a circle. So this is very straight. As you're being pressed on it, you're going to be making this super, super straight. So what we're going to do is you need to kind of give it a bit of a curve. And the best way to do that is you just get the corner of the table, being nice and careful, and you just pull it down like that. The more you get it to curve, the more easy it's going to be. See how that's not nice and straight anymore. It's got a bit of a wonky curve. And that's good. That's what we want. Then the next thing you do is you just open up just the last fold. So can you see, just I've opened up the last fold, and then what we're going to do is you roll it and you just put one of the sides into the other side like that. And then you fold that bit back over. So you're refolding that fold. And what you do is, I'm just going to start off where I can see. Just couldn't see what I was doing there. So you just fold it together and refold. Now it is really strong when it's happening, so you can be quite forceful with it. And then when it's in, you refold that fold all the way around. Don't be worried about giving it a rip. It's really, really tough. The grown-ups need to help you at the start, so it is quite tough to do. And then we go around. So I'm getting round, further around. It's starting to look a little bit like a tube, a little bit circle shape. There we go, pretty much there. Excellent. Now you don't have to use sellotape, but you can use a sellotape just to put it onto that little bit there and just to screw it all in. I'll use sellotape just. So you see we've got this like little tube shape on the top. It's not perfectly circle yet, but hopefully it will be soon. So see it's a nice tube. And then what you do on the bottom is you just fold over just a tiny, tiny bit like that. So see, and then you take that fold a tiny bit, and then you take that fold all the way around, just to give it that kind of a little lip on that bottom. So just give it. Again, I'm doing this super, super quick. But when you do it, you can do it a little bit tidier than I am. It doesn't take very long there. So it's a nice tube. So that's all you need. A nice tube. You put the fold on the top. I put a little bit of sellotape on mine, and then you've got the fold on the bottom as well. Now, if I asked you what will travel further, this paper aeroplane or this tube, I think most of you would probably say the paper aeroplane. Now, sometimes they do. However, these can travel really, really far. I think these have the world record for kind of the longest traveling paper aeroplane. These can travel really, really far. But what you need to do with this one is you have to spin it. So you throw it like an American footballer who throw it like that, and you give it spin. So when you throw it, you spin. So it spins like that, and it spins round. Now, what happens to these? The reason why this flies, because you think it hasn't got a wing, well, actually what happens is when you throw it, so you're giving it thrust, so you make it move through the air. But because of the shape of it, it's like a tube, the air starts to move in like that. So the air in here starts to move, so the air in here starts to move quicker than all the air around here. So the air in here is at a lower pressure. Now remember I said things try to move from a high to a low pressure. So what happens is it's high pressure all the way around it. So it just kind of stabilizes. And then when you spin it, it gives this thing called a gyroscopic effect. So it kind of spins it and it just holds it true, so it travels through the air more. But then again, when it slows down, it loses thrust, and eventually it'll bring back down because the air's not moving through. So it's a really amazing one to do. I think I'm going to give mine a little bit of a throw. See if I can, so I'll just show. Can I throw out the camera? No, I won't. I'll probably not it over. I'm going to throw. Excellent. So that's went to the other end of my kitchen. They'll go really far. That would have went even further. So they're really fun to do. I've got a spare one here. So they're really fun to do. Now remember I said also, the Grand Prix car in Cars 2 called Francesco Bernoulli. Now, if the Grand Prix car, a racing car, well, they don't fly. They try to stay on the track, but that's why, because what they do is it's almost like an upside down aeroplane. Whereas we use air pressure to make things fly, racing cars try and use air pressure to keep them onto the track. It makes them go faster around corners. So that's why Francesco Bernoulli is called Francesco Bernoulli. I'm just going to put these there. I'm going to give myself some space. And now we're going to go on to this little activity. Now, if you're with us on Monday, this is the one that I got you to design. If you weren't with us on Monday, don't worry, I'll quickly go through this now. I've got a little cut out of a template here. And if you want this template, you can email me at info@BigScienceUK and I can send them across to you. I can email you these little templates. Or if you want, you can just get a plate, draw a circle on the corner, and this is the bit you're going to need. So you just cut that out with some scissors, and then you need to make this into a kind of cone shape. So you just do that by folding in. Now, what I would say is to the boys and girls, if you're going to do this straight away with me live, make sure your name's drawn on it, because they might get a little bit confused in a second. Now, what the main thing is as well, when you're doing it, it has to make sure that the top, the hole on the top is as closed as possible. So you don't want any air to escape. I'm just going to put a little bit of sellotape on there. And also what you must make sure is that the cone can actually sit on top of your bottle like that. So it sits like a little hat on top of the bottle. So I'm just going to leave that there. Now, just while you're doing that, just to give you a few seconds to catch up, remember I said at the start when I was talking about air pressure and how much air is in a certain space. So you've got to think of this, the air pressure. If I squeeze this bottle, can you see it there? If I squeeze the bottle, it goes in and then it pushes back out. Now, when I squeeze it in like that, the reason why it pushes back out is because of air pressure. So we've got to think, if this was full of water and I squeezed it, the water would just jump out the top. Just like the air is coming out the top now, you can feel it if you put it on your face. So if you get your bottle and give it a little squeeze on your face, you'll feel a little bit of air push against your face. That's because when you squeeze, it's pushing it out. But when the lid's on, my bottle here, when you squeeze it, remember, it's got nowhere to go. So the pressure builds and then pushes it back out. So the reason why the water would come out when you squeeze your bottle or the air comes out is because when you squeeze the bottle, you are making the volume smaller. So the volume becomes less. So that's why it pushes out. There's only so much water you can fill in. If you squeeze it and make it smaller, it pushes the water out. Now the same happens with air, and that's how we're going to make our rockets fly. So when you have a bottle and you make the volume smaller, you increase the pressure. So you make the pressure higher. So put that there. So what we're going to do is we're going to increase the pressure. We're going to make the pressure in this bottle higher by making the size of the inside smaller. And what we're going to do is, and just all together, we're going to bang our hands together. Now, if you bang your hands together now, a little bit, it's quite loud, put more energy into it, the clap gets louder, put even more energy into it, and the clap gets really loud. So we need lots and lots of energy because we want to make this bottle size to volume get much less really, really quickly. And if we do that, we make the pressure increase, so it goes up really, really quickly. And then what happens, because we've got our top little rocket on top, the pressure will give it some force and it will push it up into the low pressure. And it will give it force, it will rise up, and it will keep on giving it force until the air resistance slows it down. And then what will happen is gravity will then take over and it'll bring our rockets back down. This is a good idea to have your name on because these might go flying all over. Also, a little bit of a safety talk. Don't lower the top when you're doing it. You always sit right back and bang it like that. And the really important thing is that you get the bottle at the same time. So you'll bang your hands together like that. Now I'm going to do a countdown. You have to do a countdown before you do a rocket launch. So even if you're watching this back in the future, you still need to do a countdown and do it all together. So we'll start at 10, and then we'll go down to 1, and then we'll say, we have liftoff. You have to say, we have liftoff before you make a rocket fly. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have lift off. Excellent. That went right the way over there. Hopefully yours all flew over the place as well. So that is just a little way of making something fly by you changing air pressure. Now, I did talk about toilet roll at the start and making toilet roll fly. So I'm going to do a little quick demonstration for you all with my toilet roll. Now remember, I said if I blew on it, it gave it this thing called lift. It lifted it up, but it didn't really fly. So I'm going to make the toilet roll fly. Now, one of the reasons why the toilet roll didn't fly is because of something we talked about on Monday. We talked about a force called friction. So friction is a reaction force and it acts against something. So if I try and push this toilet roll along here, friction acts in the opposite direction and slows it down. Now, if you look at the toilet roll inside, the toilet roll has a surface. My fingers have a surface. So friction will act against these as well. So friction is stopping the toilet roll turn round. And I need the toilet roll to turn round for all the toilet roll to come off. So I've got to try and reduce the friction, so make the friction less. So I have got this. This is just a wallpaper roller without the roll on. So if I put this toilet roll onto here, you can see now there's a lot less friction. So now if I give it a blow, right, still didn't move. Now, remember, when I said we wanted things to fly, there was some forces. There was gravity, which is pulling it back down. We've got lift, because it lifted it up a little bit, but there was another thing, and it was thrust, so power. So if you think aeroplanes have big engines on, I can only blow so much air onto this toilet roll, so I need more power. So fortunately, I have brought a power tool. Now this definitely blows more hot air than me. So what I'm going to do now is I'm going to use this to blow this on here. And this time it's got a lot more power, so hopefully it will fly. Now this is the bit where I've got to try and knock something over. So we do a countdown again in 3, 2, 1. So it flew all over the kitchen and I managed to not knock anything over and I haven't broke anything. So I made the toilet roll fly, and again I made the toilet roll fly because the difference in air pressure and then giving it thrust. So that's a lovely, lovely little one. You don't even have to have a leaf blower. If a teacher wants to do that, I hope you can use a hairdryer, but I haven't got a hairdryer, so I use a nice leaf blower. Now that's the last little thing for you to do today, apart from your little tasks. Now the little tasks that I'd like you to do have just been blown away. So I'm just going to get that out there, is you're going to design your plane first. So you can make either a tube plane or a tube plane or a paper aeroplane. Remember, nice big wings. But what you would do is when you've got your piece of paper, make sure it's a nice, crazy, colourful design, colour it on one side, colour it on both sides, give it a name so you know it's yours, and then make it after that. And then after you've made your tube plane or paper aeroplane, experiment and see who's can travel the furthest. If you're doing it at school, you can do it as a class and see who's can travel the furthest, and then think why. If you're not at school and you're at home, just see how far you can get it to fly. See if you can get your tube plane to fly all the way over the other side of the room. So that's what I'd like to see. And remember, if you do the after task at school, there's still a competition running. I've had some brilliant entries so far. Use the hashtag #ScienceWithNeil or email us at info@BigScienceUK. And we're going to give that prize out at the end of the little certificate that we'll send to your school. Also, I nearly forgot, we'd love you to give this little video a like or subscribe to our YouTube channel, because remember there's loads of other stuff on there as well. I am going to give some more shout outs as well, and to two of the same schools as I gave yesterday. It's Miss McGill's class, Year 3 class at St Cuthbert. The photos have been absolutely brilliant so far, and also St Mary Magdalene's and Save. Absolutely brilliant work. So I'm loving seeing all this so far. But keep them coming as well, and we'll always give you a shout out whenever you're doing our little science sessions. Now, next week's, I keep on saying next week's session, tomorrow's session is going to be looking at water. Doesn't sound very exciting, but it'll feel like a little bit more it might, all the stuff we've been doing so far is kind of physics really. So this is going to move a little bit away from that. So what you're going to need is you're going to need a tray and you're going to need some water. Now you're going to fill the tray with water, but you don't have to do that straight away. If you haven't got a tray like this, it could be a bigger tray or even just a little plate like that. You're also going to need some cardboard. I'm just going to use a cardboard box like this, a cereal box. Now I've just lost my design, so I'm just going to quickly do the design now of what shape you might want to cut out of your cardboard box, so you're ready to go. So when you do it, I'm just using a bit of paper to show you the shape that I'd like you to all have ready to go. If you want to do it with me live, the shape that you're going to need is that shape there. So we all see it's like a house with its door cut out, and that's the shape out of cardboard that you're going to need. You'll also need just a tiny, tiny bit of washing up liquid, and also a plastic cup, or I'm going to use a glass or a plastic cup, and then either some paper clips. I've got some metal paper clips, it has to be metal ones, or some 1p or 5p pieces. That's all you're going to need. If the teacher or grown up is feeling brave, a little bag and a pencil. I'm going to use a big bag. I might get a bit wet tomorrow, so that's always worth watching for. So is that everything? Have I forgot anything? I always forget. After the session, I always remember something. So that's all the stuff you're going to need for tomorrow. Again, all the other sessions are already on this channel, and this one will be available straight after. So if you want to watch back to make your paper aeroplane or tube plane, the instructions will still be there. For the tube plane, there's already a separate video which is broken down a bit more. I think there's a few images and stuff on there as well. So please go and give that a like and give that a little watch as well. But for today, that's it for me, and I will see you all tomorrow at 2 o'clock for our water science experiments. So thank you again, and bye.